Okay, let us talk about the Marr's operator. The Marr's operator is another way of doing edge detection. Instead of looking at the gradients or differentiating the intensity of the pixels, we do the Laplacian of the intensity of the pixels. So this means instead of taking the first derivative of the pixels, of the intensity of the pixels, we take the second derivative of the pixels. So this way, instead of looking for the peak of the pixels, we will look at the second derivative, which is where the pixels crosses zero. We call this the zero crossing of Laplacian. Actually, I'm just kidding. We just call this zero crossing. So instead of looking for the gradients, where we try to find where it maxes out the gradients, we will find where it crosses zero. If it crosses zero, then we would say that we have found an edge. So this is a good way of getting rid of the threshold issue that we see in Sobel and Prewitz operators, where we need a threshold to tell us whether there exists an edge or not. Unfortunately, that's not how it works in real life. There are too many edges, and almost all of them would cross the zero boundary. So you would get a lot of redundant edges. So you'll still need a threshold, but it's a different kind of threshold. Now, this threshold would essentially look at the slope in which it crosses the zero boundary. So if it's a very gentle slope crossing the zero boundary, then we might say that's a false positive. There are no edges there. But if it's a very steep slope across the boundary, then we would say then there might be truly an edge. If the slope is greater than a threshold that we have set, then we would say that there is a edge because it's a very steep zero crossing of the image. Then that would be an edge. Now that's essentially my understanding of the Marr's operator, where we will use the term Laplacian, which is taking the second derivative of the original image, and we will find the image differentiated twice along the x-axis and the image differentiated twice along the y-axis. And then we will use similar calculations from there to get to the Laplacian edge detector. So a kernel for Marr's operator is going to look something like this. Where instead of having -1, -2, and 1, here we would do -1, -4, -1, 1, 4, 1, 0, 0, 0. So we can see that the slope is much steeper. And that's how you would do Marr's operator.